Gold recovery from RAM is easy until you go after the hidden 24-karat bond wires inside the chips. Today I'm processing 1 kilogram of RAM BGA IC chips. Follow along to see what works, what doesn't, and how much gold I recover. For these chips, I've already leached them with hydrochloric acid to remove the tin from the solder balls. And so the next step is to burn these to remove all of the volatiles that are contained in the epoxy and plastics of the chips. The goal with this step is to burn off the volatile gases. All those flames are just that. We should have no smells or black smoke. Once the flames are gone, we are left with just the carbon. Once done, we're basically left with this glowing red IC chip charcoal. Pulling these out of the furnace, and I will let them cool before moving on. Next, we want to grind the chips into a very fine powder. I've done this using the shake it in a bottle method. I've used my oyster blender, and what I have found is those all take a lot more work. On the other hand, this grain grinder used for home brewing is relatively fast and efficient in getting to a really fine mesh quickly and efficiently. That was about 30 seconds of actual grinding. We have a very fine powder in here now. We're going to go ahead and dump this batch into the sifter and continue to grind the rest of the chips and put them all in there as well, and then I'll show you the sifting process. So this is my sifter. It's actually a flour sifter for home bakers that grind their own grains. I'm using this because I found all the other methods to be, again, labor intensive and a bit messy. I'm hoping this goes pretty quick. It uses a vibrating process to put the powder through an 80 mesh screen, which should be sufficient to release the gold bond wires. As it's coming out, I see that the dust is flowing pretty good. I'm going to raise the pan up, use a gold pan to control the dust, just to keep it a little cleaner. So that made quick work of sifting our IC chip powder through that 80 mesh screen. Take a look and see what we have left in the strainer. There's a little bit there. I'm going to go ahead and dump that, and we're going to put this back through the grinder and back through the sifter and capture as much of it as we can. Be sure to get any powder stuff to the lid off before we dump it into the sifter. So we've sifted our material. Let's see what we have left here. Still a tiny bit left. I'm going to save that off. I'll use a microscope on it. See if there's any gold bond wires in there. If so, we'll put it in a different batch. If not, well, that will go in the trash can. I'll go ahead and get all the powder stuck in the bottom of the sifter cleaned up, and we'll move on to our next step. With our powder, we're now going to ash it. This essentially will turn the carbon into carbon dioxide gas and leave us just with the ash. Carbon is a gold thief in the leaching process, so getting rid of it is a key step to making sure that we get our gold. To release the carbon is exposed to oxygen, so we continue to stir this, bringing the black carbon to the top until we have a fine white powder. So up to now, I think I have a pretty efficient process, but here's where I'm going to start doing some experimenting to see if I can do a better job than I've done in the past. First, I'm going to take our powder, and I'm going to do a hydrochloric acid leach. In the past, I'm certain that I've had iron or aluminum or both that has made it into the powder, which has caused for some very interesting aqua regia leaches and process in the end. So I'm going to go ahead and add hydrochloric acid. I'm going to put this in the heat and let it bubble for a while. Hydrochloric boil's been going for a while. I'm going to go ahead and pull it off the heat and then filter out the liquid and save the solids. Off camera, I took the first batch of the solids that we filtered and I re-incinerated them to remove any chlorides. I'm putting them up on the heat now, and I'm going to do a nitric boil to see if we can remove any more base metals before moving on to the gold. I'm not going to do that with the remaining solids. I found re-incinerating it and those chlorides was a noxious process and one that I'm not going to repeat. It just wasn't something that I felt comfortable with. Remaining solids have filtered. I've rinsed them to get as much of the chlorides out as I can. I'm going to go ahead and get rid of the junk we pulled out with the hydrochloric. Put these into a smaller beaker, and I'm going to go straight to aqua regia here. The reason for that is because we're not cleaning out all the chlorides. I can't really do a nitric boil. That will form aqua regia and start dissolving gold anyway, and we certainly don't want to lose any gold that way. I'll add hydrochloric acid to cover the solids. I'm going to add 6 or 8 milliliters of nitric acid. This is probably more than we'd actually need for the gold, but there's probably base metals in there, and I want to be certain that we get good AR circling around all of those solids so that we can leach out as much of the gold as possible. I'll keep adding nitric to both solutions until the reactions stop. So our nitric leach has completed. I'm going to go ahead and filter out the spent nitric. Again, I'm going to save the solids. And I'm going to rinse the little bit that's left in that beaker out and just get as much nitric out as we can as opposed to putting it through the filter. I'm going to put this all back in the beaker, and we're going to do an aqua regia process on it as well to extract whatever gold might be in there. Again, we'll add our hydrochloric acid to cover the solids. Get everything kind of mixed in there nicely. Then let's add some nitric acid to leach our gold out of the solids into solution. All right, upper region process is finished. So we're going to go ahead and filter out our gold solution from the leftover solids. I'm going to hang on to these solids because I'm really not sure exactly how we're going to do here, if we've got everything or not, and I may want to come back and revisit them at a later time. So our first batch is filtered. See our solids, we've rinsed it with water a few times. We'll go ahead and put this into a beaker. I'll do a quick stannous chloride test to make sure we have gold in solution. We do. Don't need to look at the Q-tip. I dropped stannous in our solution by accident, and you can see there's plenty there. I'm going to go ahead and drop the rest of the gold with sodium metabisulfite, SMB, so that we can get around to recovering it. I'm not expecting that much gold. It appears we may have some excess nitric in here as well because our gold is coming out and going back into solution. We'll go to keep adding our metabisulfite until the gold drops and starts to settle. So the initial beaker is finally settling. I'm going to go ahead and filter the second beaker that we did the nitric boil on. You see our solution's coming through. Still looks to be there's some base metals, copper, whatever in there based on the color. I'm going to go ahead and get this into a beaker. We'll also do a stannous chloride test on it. Off to the side this time. Our stannous chloride test on us is negative, which is surprising to me. Setting up that negative test aside, I'll deal with that later. In the meantime, our other stuff is settled. We're going to go and pour off this solution. I think that's iron that's causing that brown color in there. Not sure why that is, given the hydrochloric oil, but there it is. There's our gold, though. And so we'll go ahead and get this into a smaller beaker. We're going to wash this gold up and get it cleaned up and dried. I'm going to start by filtering it. We're just going to do gravity filtration. Remember that drop of stannous chloride I got in there. It creates colloidal gold, which is very, very fine. We'll go right through this filter. We're going to have to filter this a few times to capture all the pieces as we keep clogging the filter up. Most of the gold is in the filter now. There's a little bit at the bottom of this beaker. I'm just going to go ahead and reuse this and redissolve and reprocess, re-refine that gold we captured. And so I'm going to add in our hydrochloric and our nitric. We'll let this go ahead and dissolve again, and then we'll refilter it, wash it, dry it, and see how much gold we got out of it. So our filter solution is looking pretty clear. I'm going to go ahead and rinse it down, and then we're going to drop this gold again with the last little bit of SMB I have in the lab. Having to order up some more. Stannous chloride test looks fairly positive, so we'll add in some more SMB and try again. Again, we're getting color, but you can see that brown, which usually means it's not gold, but it does turn purple a little after that. So we're going to add just a little bit more. Try one more time. And this time I think we're good. Our gold is settled. We're going to wash off our water, do a hydrochloric boil, and then several hot water washes. We're going to go ahead and dry our gold and build it up and see how we did. Okay, well, here's our little gold bead. Dunk this in the water. It's not much at all. Um, Gold there. We have some impurities for sure. Seems to be a coating on the one side. How much? It's like 1.18 grams. So overall, not a whole lot. I'm sure there's gold I left behind in our solutions and solids that I'll be revisiting later. Overall, I was very happy with how the first part went. I thought the grinder, the sifters, all work like a champ. There are improvements to be made in getting the gold out of the ashes, though. Stay tuned. I have hundreds of pounds of these chips to process, so lots more to come. Thanks for watching. Please like, subscribe, and comments and suggestions are always welcome. Thank you.